Welcome back. In the second part of this tutorial about Michelson, we are going to write the transfer entry point of our contract. Now we have the parameter and the storage that's set up correctly. So we are going to start writing the instructions to manipulate the parameter and the storage in order to make a transfer happen when a call is made to the contract. The first thing that you have to know is that when a contract is called in Michelson, the first value that's going to be pushed on the stack is a pair. The pair includes two values. On the left side, you have the parameter that's sent to the contract, and on the right side, you have the current storage. The first thing here that we would like to do in our code is that we want to separate those two values, like to push them on the stack, but not as a pair, as two different values. So we are going to use the unpair instruction. So the unpair instruction is going to take a pair and it's going to push the two values separately on the stack. So you can see it here that's what happens. So we have here on the left the parameter and on the right the storage. So the parameter is of type OR. So it means that when the user is going to make a contract call to our contract, they are going to choose either this branch or this branch. And so that's why we're going to check now in the code of the contract, we're going to check like which branch was chosen by the user to determine if it's a transfer operation or if it's an approve operation. In order to do that, we're going to use an instruction. It's called if left. So if left is going to check like if it's the left side of the OR, then it's going to run some code. And if it's the right branch of the OR, it's going to run another piece of code. So here we're going to put the code that's going to run if transfer entry point is called, and here we are going to run some code if the approve entry point is called. Here we have some errors from the compiler, and I like to silence those errors, so I can really focus on the errors that are happening in the code that I'm writing. So like for example here, if I drop the parameter, and here I drop it too, now we have a clean stack. So here we're going to keep it here, and that's going to be for the third part of this tutorial. Here we're going to focus on the transfer. So let's just write some comments. And by the way, that's how you write comments in Michelson. You put the hashtag and then you put your comment, and those comments are going to be ignored by the compiler. The approve entry point. Okay, so now we can focus on our transfer entry point. So here we are going to have this kind of value on the stack. So there are multiple things that we're going to want to do in the transfer entry point. First, we are going to check who is sending the transaction, because if this address if it's the same address that's sending the transaction, then there's no problem. We can just run the transaction because the owner of the account is the one sending the transaction. But if you remember, it's also possible to approve addresses to transfer tokens on your behalf. So we also have to check if the address that issued the transaction is different from the from address. Then we are going to check if that address is allowed to perform that transaction. So that's what we're going to do here. One of the things that we are going to do a lot in Michelson is duplicate values. Because most of the time when you are going to use a value that's on the stack, you're going to consume it. So it's going to disappear from the stack after you used it. So that's why very often you are going to duplicate values on the stack so you can use them later. And in order to do that, we use an instruction that's called dup. So dup is going to duplicate the value that's on top of the stack. So you see we had the parameter here for transfer, and now we have it twice. Okay, so this parameter is a pair, and we would like to unpair the values that are inside, so we can use it. So we are going to reuse the unpair instruction like that, and so now we have here the address from that's pushed on the stack, and here we have the pair with to and value. And at this point of the code, we are going to focus on the address, so on the from address and the address that sent the transaction. So we are going to duplicate this value again in order to check it. And so we want to compare it with the sender of the transaction. So there is an instruction in Michelson called sender. And this instruction is going to get the address of the sender of the current transaction. That address can be an implicit account address, but it can also be a contract address. So you have to be mindful of that when you code in Michelson. Sender can be an implicit account, or it can also be a contract. So now you can see that on the stack we have these two addresses here. We have the address, so the address that sent the current transaction, and the address from. Now we are going to compare those two addresses because we want to know if it's the same or not, because we're going to have two different behaviors if they are the same or if they are different. So in Michelson you are going to have a type of instructions that's called a macro, and macro is just a kind of instruction that's going to make it easier to write multiple transactions at once. And here we are going to use the if compare not equal macro. So we are going to check if the two addresses are the same or not. If they are not the same, here in this case the sender is different from the spender. In this case, sender and spender are the same. Okay. So in the second case, it's going to be pretty easy. So we are going to deal with this case first, when the sender is going to be different from the spender. Now in this branch here of the condition, we have to check if the sender is allowed to spend tokens on behalf of the spender. In order to do that, we are going to fetch in the storage here this map. And this map is a record of who is allowed to spend tokens on behalf of a user. So if we go here, you can see that we have the storage here. So we are going to duplicate it in order to check that value here. And so you remember we had this dup instruction here, but dup is going to duplicate the value that's on top of the stack. And here it's not on the top of the stack. So it's possible to bring it to the top of the stack and duplicate it. So what would be better here is to keep it at the bottom of the stack and just duplicate it and push a copy on top of the stack. So we are going to be able to use that dup instruction. But this time we are going to pass a parameter to it, and the parameter is going to be the position of the element in the stack that we want to duplicate. And here the position is 1, 2, 3, and 4. So dup 4, and now you can see that I have the storage here on top of the stack. I mean, I have a copy of the storage on top of the stack. So we are going to be able to use that copy and check if the sender is approved to transfer the tokens. Here on the stack, so we have the address from. Okay, so what we're going to do is that we're going to use an instruction called swap. And so swap is going to change the order of the two values on top of the stack. So here we see we have the storage and the address. So this address is from, if you remember, that's the address from. So with swap, we're going to bring that address on top of the stack. And now after swap, we're going to use another instruction called get. So get is an instruction that you can use in order to get a key from a map. So you see here the map that we have. We're checking the storage at the moment. The storage is a big map, and we have here an address. So we're going to check that the address from exists in the storage. And that instruction get is going to return an option. So the option is going to be none if the key doesn't exist in the big map, or it's going to be some, and then some is going to wrap the value that was found in the big map. So here we can use the instruction if none. So if none is going to check if the value that we have here on the stack is none or is some. So here, if the value is none, it means that this one from doesn't exist in the big map. In that case, there's no token to transfer. So we can make the contract fail because this address here doesn't exist in the big map. So there's no token. That even later, that there's nothing we can do at this point. No? So we are just going to make the contract fail. And in order to do that, first we want to give some message. Like maybe you're going to write a DApp. And you would like to get a message back from the contract if there's an error, if there's a problem. So at this point, you can use an instruction that's called push. That's going to push a new string. It's going to push a value on top of the stack. And in this case, it's going to be a string. And for example, we can call it not a user. Okay. And then we can use fail with. So fail with is an instruction that's going to stop the execution of the contract. And it's going to revert every change that was made back to the state that the storage was before the transaction happened. So as soon as you call fail with, everything is cancelled, everything is reverted to the state it was before. So there's no change. It's like nothing happened. If the value is sum here, then it means that the address from exists, and then we are going to get on the stack, we're going to get this value. So this value is very interesting because that's the one that we are going to use. So let's just put some user doesn't exist, and here the user exists, and we're going to check if sender is allowed to transfer tokens. So now that we have that value on the stack, what we can do is first we want to duplicate the value, so we can reuse it later. In order to reuse it later, what I like to do when I write Michelson is try to put that value that I will reuse later at the bottom of the stack, so I know it's there, and then I can bring it up later, you know, so it doesn't mess with the other values that I have close to the top of the stack. And I'm going to use an instruction called dug_for, you know, so we're going to see here, you see here we have two values, sum. So they are the same value because I duplicated them. And with dug_for, I'm going to tell Michelson to put the value that's on top of the stack at the position 4 in the stack. Now you see it's here, it's at the bottom of the stack. So here I will keep this value for later. I'm going to use it later. So it's better to duplicate it and put it at the bottom of the stack rather than getting it back from the big map every time I need it, because it consumes more gas. So that's why I'm doing it like that. It's going to be more gas efficient. Okay, now that I did that, I can start checking if the sender is allowed to spend the tokens. So in that case, so you remember here I'm getting a pair, and I'm not interested in this value here. I'm just interested in the map. So I'm going to use an instruction called CDR, and CDR is going to get the right field of a pair. So you see now I have the map that I'm interested in on top of the stack. After that's done, I'm going to duplicate it again because I'm going to use it later. And now I can, once again, I can push the address of the sender on top of the stack. Because that's the address that I will be looking for in the map. And just like before, I use the get instruction here to see if that key exists in the map. And once again, I'm going to use if none. So here in this case, it means that the sender is not allowed. And in this case, the sender is allowed. And if the sender is allowed, we're going to check for allowance. So we are going to check that the sender is trying to transfer an amount of tokens that they are allowed to transfer. But first, let's check this one. So here the sender is not allowed to perform that transfer. So in this case, just like before, we are going to make the contract fail. So first, we are going to push a string, and here there is an error message here in the standard. We're going to use this message, not enough allowance. So in this case, I mean, there's no allowance at all, but technically speaking, that's also not enough allowance. So we are going to use that error message to indicate that the sender is not allowed to perform that action, and then we'll make the contract fail. Okay, now let's go in this branch. Now that we know that the sender is allowed, we can check that. So here first, in order to check it, let's have a look what we have in the stack. So you see we have those three values here. So we are going to, so now I need to have this the value here. I need the value so I can check it against the allowance that's provided for this user. So I'm going to use, there's an instruction called dip, So deep is an instruction that's going to protect the first value of the stack, and it's going to run the code that you put between the curly braces, starting from the second position on the stack. So it's going to like jump the first value on the stack, and it's going to start working on the stack as if the first value didn't exist. So you see, for example, here I'm going to write this code here, and we're going to check what it does. So you see that it brings that pair on the top of the stack. I mean, not on the top of the stack. No, it brings it swaps the position of the pair and the map. So you see there was that map and pair. So now we have pair and map. And then here you see that the sum is still here. No, that value, you know, that's expected to be here. This one was left untouched, and we just swapped the value that was at position 2 with the value that was at position 3. Now I want to bring the pair on the top of the stack, and after I bring it there, I can use CDR again because I want to get the value here. So that's what I'm interested in. I want to know if the amount of tokens is equal or less than the allowance for this user. Let's duplicate it because we are going to reuse it. And now what I want to do is I want to move some of the values in the stack that I need to use. So first, I'm not going to touch this value here. And then I'm going to duplicate the second value in the stack and then swap their position. So here I'm just like putting all the values in the right position so I can compare them together. And that's actually what I'm going to do here. If compare greater than, I'm going to check if the value passed as a parameter is greater than the allowance. And of course, if it's greater than the allowance, it means that it's a problem. And we're not going to perform that transaction. So as before, string like that, I still have it here, yeah, not enough allowance, and we make the contract fail. So here we know now that the amount of tokens that was requested to be transferred is greater than the allowance that's been set by the user, so we make the contract fail. If the value is within the allowance, we can now update the allowance in the map. So when we process the transfer, we already have the map for allowances that's updated, and then we can return it as the new storage at the end of the execution of the contract. Value is within the allowance. Okay, let's have a quick look at our stack here. Okay, so you see we still have the map here, and you can see that you can get lost very easily with Michelson because there are no annotations for the values that you have in the stack. But so you have to be careful what you do. First, let's swap those two values on the stack, and so this one is the allowance that was set by the user, and this one is the value that we duplicated a little bit earlier. So now we can use an instruction that's called sub. So sub is just going to perform a subtraction between two values, and it's going to return an int. So here you can see that we have two values of type nat, but sub is going to return an int because it's possible that it's going to be a negative number. Okay, so that's what we're going to check here. Here we're going to use an instruction called isNat. So isNat is going to check that the number is a natural number, so it's 0 or above. And here it's very important because if the number is negative, it means that there's a problem in the contract or in the value that was set as an allowance. So isNat is going to return, as you can see here, an option of type nat. So it's going to return none if the value is negative, or it's going to return some nat if the value is 0 or above. So that's what we're going to check here. If none, here, if it's none, then there's a problem, you know, right? Unexpected negative allowance and fair width. Otherwise, if it's as expected, we can update the allowance. Okay, so in order to update the allowance, we're going to use here this map. Okay, so what we have to do in order to push a new, so here this value that we have, it's the remainder of the subtraction. Okay, so in order to push it in the map here, we need to organize the stack in a certain way, and what we need is to have in the first position we need the key that we are going to update. In the second position we are going to have need a value of type option with a parameter of the same type value in the map, and then we need the map. So we need those three elements in this order on the stack. So that's what we're going to do here. So first we are going to wrap the remainder of the subtraction in an option type, and in order to do that we are going to use the sum instruction. Then we are going to get the address of the sender. So remember that's the address that's allowed to transfer tokens on behalf of the spender. And now you can see that we have those three values in the right order here. So the key for the map, a value of type sum with the type of the value of the map, and then the map itself. And then we use an instruction called update. It's an instruction that you use with maps and big maps in order to update a value in the map or the big map according to its key. So now we have that map here is the updated one with the new allowance for the spender. So now we have to push that map inside the storage. So first we want to get here this value back on the stack, at the top of the stack. We are going to swap it with the map. And then we are going to use update with two. Update here is going to be used with a pair. Okay, so we have here that sum is that value that we got from the storage that's associated with the spender's address. And so when you use update with a parameter, it means that you have a pair on the stack, and you are going to update one of the branches of the pair. So here it's a little bit more complex to explain, but I will leave a link in the description so you can understand how to update a pair. But that's what we did here. You see that the map disappeared from the stack, and now the map is here in the pair. So we updated the pair that's on stack now. And just like before, we are going to wrap this new pair. So the pair is this one. Huh? That's the one that we updated. So we are going to wrap it in sum. Now we are going to get back the values that we duplicated a little bit earlier. So you see we're getting those values back on top of the stack, so we can update the storage. We are going to use deep2 and then swap those values. So deep is also that kind of instruction where you can pass a numeric parameter, and it's going to skip the first value on the stack, and deep2 is going also to skip two values on top of the stack. So now we can work on the storage. So you see like one value, two values, and then deep2 ignore those two values, and it swapped the parameter and the storage. And now you see storage parameter, and now we have those two values here that were ignored by deep2, and then we have storage and parameter that were swapped. Now our values are almost in the right order. We have to swap them last time. So now we have the address the address from, and then we have an option with the new value for the big map, and we have the storage here. And now, as you might have guessed, we can use update to update the storage. So now we are at the end of this this part of the execution. We updated the allowance of the sender of the transaction. And you can see here that what we have at the end of this execution is so the new storage and the parameter. But here we're going to have a problem because that's not the same here. It's not the same stack that we have, you know? So we have to do some cleanup because you see we have like unpair, so we have different stuff. So we have to do a little bit of cleaning because okay, this part is like the easy one. The sender and the spender is the same, so we don't need to do any checking or anything. But we need to have at the end of this condition, if compare not equal, we need to have the same stack type, whatever branch that we use. So here we're going to use drop. So you're going to see like if I use only drop, I'm dropping only one value, you know, and you see I still have here this one that comes from the duplicating from unpairing that pair. So drop can also take a numeric argument if you want to drop more than one value. Like for example, if I want to drop two values from the top of the stack, then I can write drop 2. And you see I'm left with parameter and storage, which is almost the same like storage parameter. So I just have to swap them. And now I'm going to be left with the same here. I'm going to be left with the same stack, so the storage and the parameter. So now we can start processing the transfer. Now all the checks are done. Everything is fine. Everything is okay. We can start processing the transfer. Let's start by duplicating the storage here. And we are going to use dog2 in order to keep a copy of that storage at the bottom of the stack. Next, let's use swap. So we're going to get the transfer parameter back on top of the stack. So now we are going to use it. And so if you remember that parameter is a pair, so it's a nested pair. So you can see that on the left side we have an address, but on the right side we have another pair. So it's possible in Michelson to unpair everything at once in one instruction, because otherwise you should do like unpair, and you will see unpair is going to push address and pair, and then we have to go swap, okay, and then unpair. Okay, and that's a little bit tedious. We have 3 instructions just to remove all those values from the nested pair. Instead of doing that, we can just use unpair 3. And then unpair 3 is just going to unwrap all those values if it's a simple nested pair like that. The parameter is going to change according to the level of nested pairs that you have. You know, but here's just a simple one. So now we have from, to, and the value. Let's duplicate this value here. We are going to put it at the bottom of the stack so we can use it later. Let's bring back this value. So now we have our storage here because that's what we are going to work with right now. Swap. So now we are going to find the key that's the address from. That's the address from which the tokens are going to be transferred. So we are going to use that get instruction like we saw before, and we are going to check if we find it. So here, of course, if we don't find it, then there's nothing to transfer, and we are going to make the contract fail, just like we did earlier. Not user. Okay, and then fail with. But if we find it, then here we're going to, on the stack, we're going to get that sum here is the value in the storage. And so now we can work with that, and we can update we can update the token balance for this user. So let's duplicate this value so we can use it. And this value is a pair. Here it's a pair. Token balance is this one, the left side of the pair. So in order to get the left side of the pair, so the current balance of the user, we're going to use CAR. So remember, CDR is to get the right side of the value that's on the right side of the pair. CAR is the one to get the value on the left side. Now I'm going to bring back this value, which is the amount of tokens that are requested to be transferred. Let's duplicate it. I'm going to keep that value for later. Swap. Okay. And now we can, at this point, we're going to compare the balance with the value. Okay, so just to make sure that the user has enough balance to process the transfer. So we are going to subtract the amount of tokens requested for the transfer from the balance, and we are going to check if the value that we get after the subtraction is a positive value. Because if it's negative, it means that the user doesn't have enough balance for the transfer. So that's what we're checking here. And of course, if the value that we have now on the stack is none, it means that the user doesn't have enough balance. So here too we have an error code in the standard, not enough balance, that we are going to use here, and we make the contract fail. Okay. Otherwise, if it's good, then we can update the spender's balance. Oops, spender's balance. Okay. So in order to do that, we are going to. So now we have on our stack the new balance. That's the result of the subtraction. So here we are going to push that value inside the pair that we duplicated a little bit before. So this pair here. And update 1 is going to push the value that's on top of the stack to this position in the pair. So that's what we want to do now. And as we did before, we are going to reorganize the stack now to get the values in the right position in order to update the storage. So we are going to wrap this value in sum to make it an option. And now we are going to use a few instructions to reorganize the stack in the proper way in order to get all the values in the right order before we can update the storage. So let's bring this let's swap those two values here and dip update. Okay, so dip, you remember, is going to protect the first value on top of the stack. So we're going to skip this value here. And now we have the address here of the spender. We have the value with the updated balance. And here we have the storage. So we write dip update to push that new value inside the storage. So here we updated the spender's balance. Now we want to update the recipient's balance. Updates the recipient's balance. So we remove the tokens from one account and we put them in the other account. So here too, there's going to be a lot of reorganizing the stack in order to get the proper values, the values in the right order. Dup, a little bit of dip swap to put the values how we need them. So now here we have the recipient's address, so the address that was 2 in this one in the parameter, and so we're getting that value out of the big map with get. Once again, we have an option here on the stack, so we have to check that it exists. If it doesn't exist, it means that the recipient has no account. If it exists, it means that the recipient has an existing account. So in this case, we will have to create the account. In this case, we will have to update it. So in order to create a new account, it's going to be very easy. So we need that pair where on the left side we have the token balance, and on the right side we have the map of allowances. So let's start by creating the map of allowances. So we're going to push an empty map to the stack by using the instruction empty map. And it's going to be of type address nat. So we are creating this map here. And it's going to be empty, of course, at the beginning because there are no allowances that are set by the user at this point. Then we're going to bring back some values that we need here. dig3. Now we can pair them. So now we have that value that we need for the storage. So here that's the new token balance that the recipient is receiving, and that's the value in the storage. Of course, we have to wrap it in an option before we can save it in the storage. Let's use swap to get the address of the recipient on the top of the stack, and now we can use update in order to update the storage. Now we can deal with the case where the recipient has an existing account. So first unpair the value that we have on the stack. So we get the current balance of the recipient and the map of allowances. We are going to get the value for the transfer back on the stack. And now we use the add instruction that you probably guessed is going to add two numeric values together. And now the only thing we have to do is to pair them again with the map of allowances. So now we have the right value for the storage. Wrap it in an option. Put the key first, and then we can update the storage. So okay, we are left with the storage, and you see there are no warning or anything. We successfully updated the storage of the contract, so we processed the transfer and we updated the allowances if the sender of the transaction was allowed to transfer the tokens on behalf of that user.